Most people overcomplicate what an AI agent is, so let's be very clear. An AI agent is a system that takes a goal, breaks it into steps, runs those steps using tools or models, checks the results, and then returns an output. That's it. Not a chatbot, not a digital assistant, just a system. We can see that the input goes through planning, execution, verification, and output. In this video, we focus on the most important part of any agent system, task decomposition, how a messy real-world goal turns into a clear sequence of actions. If you understand this, you understand why agents work when they work and why they fail when they fail. The task itself, it's this one, to research the top 5 competitors of Stripe in the payment processing space and create a comparison table with their pricing, features, and market positioning. So I do have 3 scripts for you today. First one is the single prompt, then a classical script, and thirdly the agentic approach. For the first and third one, as you can see, I'm using an Azure OpenAI endpoint. You need some way of calling an LLM. This is how I personally do it. This is a normal task. Founders, analysts, and product teams do this all the time. Why this is harder than it looks? A single prompt is not enough. This is the output of a single prompt. We see even though it's structured, it's good, it's not very specific. So multiple sources, there is no single API gives you this. You need judgment. What even counts as a competitor? There should be a structure. We want a table, not a paragraph, some sort of verification. Pricing changes all the time. A single model call has none of that. It has no tools, no memories, no way to check if it's wrong. It just predicts text. What usually goes wrong is what you see in here as well. Even though we spotted the competitors, how they compete with Stripe and all these market positioning tables that we are not really interested in. We have clear goals, and this is not what's been followed because everything is in one prompt, and we hope for the best. There are the problems that I was just telling you about. We don't have access to current data. Model uses training data. We don't have a web browsing tool, no verification source, no structured output. Data might be outdated, prices can be guessed, output format changes every run, no way to verify anything. If one more part fails, the whole thing fails. The problem is not that the model is bad, the problem is there is no control over the process. And then we have the classical solutions, how a human does it. A human analyst would search for competitors, filter irrelevant companies, open pricing pages, extract numbers, compare features, build a table on it, double check sources. It takes hours, but it works because judgment is applied at every step. However, in our script, I called it already so we don't lose time, we see that even with this information, pricing element is not found. It's very hard to extract this type of information if their websites changes continuously. They have different ways of outputting the prices and information, even though we do have the right URLs. Stuff changes, competitors change. So, as it's written here, there is no dynamic discovery. Fragile HTML selectors, this works for one site, breaks for another. Sites change, scripts break, competitor list is fixed, no reasoning, no recovery if one step fails. Classic automation works only when the world is stable. This task is definitely not a stable one. And then thirdly, we do have the agentic based approach, what an agent actually does. And we have here step by step. An agent does not think, it plans. It turns one big goal into smaller steps. Here is our goal at the top, and here is the plan. define criteria at first, what counts as a competitor, identify candidates. So we find companies that match. We extract the data, get pricing, features, positioning. We structure the output, format into a table. We verify and return. We check our sources. We flag issues. And yes, notice these constraints at the bottom of each step. We do not have assumptions. We have maximum of 10 candidates, no invented data, schema validation, source required. Each step, as you've spotted most probably already, has a clear input, a clear output, clear limits. That's literally task decomposition. And three properties make this work. Bounded scope, I mean, by this, each step has defined inputs and outputs, verifiable output, every step produces data we can check, and explicit constraints. The agent knows what it cannot do. We've spotted the difference between single prompt and decomposed agent. If one company fails, in an agent, the rest still works. In a single prompt, if anything fails, everything fails. And we can do this by looking at the code. At first, we identify the candidates, we start extracting data, we do structure the output, verify it, and as you have seen, even though the information was not found, we did hit our goal here because this is a bidentic model. It forces the output to have exactly these fields: industry, market, scale, what to include, no ambiguity. Each candidate has a name, a reason why it matches, and a confidence score. Notice this constraint: maximum 10 candidates. The agent cannot return 500 results. It's bounded. The agent can only work at official company websites, not random blogs, not forums, official sources. And this is the key. If data is missing, it says not found. It does not guess. It does not hallucinate. Constraints don't limit the agent, they make it reliable. Verification happens at every step, not just at the end. The step 5 is the most important one. I'm already here. What we do here is three things get checked. Does the output match the schema? Does the data make sense? Is every claim linked to a source? Do we have missing data? Do we have low confidence? Do we have missing sources? We flag everything. And we require human review, as you see in the verification result. Down here. Verification result. Yeah, so this requires human feedback. And if anything looks suspicious, the agent doesn't just return the result, it flags it for human review. The agent does the work, humans make the judgment calls. And of course, if the agent picks the wrong competitor early on, everything downside looks correct, but it's wrong. Verification must happen early, not just at the end. And also, top 5 competitors, top by what? By revenue, by features, by market share. Top competitors is vague. Agents don't fix ambiguity, they amplify it. Unless you make criteria explicit, the agent will guess cost and time. This task costs cents to a few dollars, and it takes around 1 to 2 minutes. Agents trade speed for correctness. It's suitable for production, but with conditions like criteria approved by human before execution, output reviewed before use, sources visible and verifiable, data freshness clearly indicated. It's not for autonomous decisions, real-time requirements, or private data access. This task can be automated with agents if those are respected. And yes, that's pretty much it. The exact problem I was talking about earlier, I wanted to show you this as well. That by including this verification layer, the right step makes the entire difference. And even though we haven't reached the best performance, we have reached our goal, because what our main goal was is that agent finds real companies without guidance, which are actually Stripe competitors. Constraints work when data isn't available. It says not found, no hallucinations on this. And the system is honest. It requires system human review. It's false only because sources count is artificially high from mock data. This demonstrates exactly what we are teaching: bounded steps, schema validation, and explicit constraints.